what exactly this data type is? This data type is nothing but
Uh-huh.
this data type is nothing but it's actually an array, or like it could be one dimension array, it could be two-dimension array or three-dimension array, like the array that we have in NumPy. So what's the main goal of our of deep learning is that whatever you get, you have to convert that thing into a tensor or basically an array. Basically, if you get an image, the main purpose, what your first goal should be to convert that image into an array of lists. Basically, you have to convert into an array. That's it. N-dimension array you have to create.
Mm-hmm.
And that's the main goal about deep learning. You convert anything that is given to you into a number, then the output you get in is a number, then you can manipulate it as per your need. Okay, now let's talk about the definition of tensor. Tensor is a multi-dimension array used extensively in machine learning and scientific computing. Okay, in PyTorch, tensors are the primary data structures similar to NumPy arrays. Okay, the similarity to a NumPy array is very, very high. So basically, a lot of operations you'll see, like basically if you have covered NumPy already, so a lot of operations you will see like np dot. So basically there is an operation called np dot zeros, right? Np dot shape. Basically, when we operate tensor, what we
Mm-hmm.
have to do is actually we have to replace that np with torch. This term called torch dot. Like basically, if you like want to change the data type, so basically you have to do np dot float uh, for the float data type. Similarly, we have torch dot float, something like that.
Okay.
Okay. So if you have a good grip in NumPy, basically you can actually work really, really well with tensor. The similarity is very common. Only the terms change. Rather than NP, you have to use torch. Okay.
Okay.
Similarity to NumPy array,
Mm-hmm.
but with added capabilities. Only difference is added capability, GPU acceleration, automatic uh, uh, differentiation. Okay.
Mm-hmm.
Okay, we'll talk about this. GPU acceleration and automatic differentiation. We'll talk about this, and I have a really good documentation. We'll talk about it. What is
Yeah.
GPU acceleration? Basically, what it does is that basically neural network or basically deep learning needs a lot of compute, and what this tensor enables it that we can use NVIDIA or any kind of GPU that we have to fasten up our computation.
Mm-hmm.
Okay, that enables this. So basically, if you're using NumPy and you're using fast compute, that won't work like more like efficiently. Whereas when you convert into a tensor, it will work more efficiently. So that's what GPU acceleration means, right?
Okay.
Now talking about why tensor matter, they generalize scalar vector and matrices to higher dimension. Okay. Now what is a scalar? So scalar is but nothing but a number. Is like just a scalar. Vector is like when we have two dimensions,
Mm-hmm.
like a 2D array or like that. Okay. Scalar is like just a number, like
Yeah.
one, two, three, four, like that.
Yeah.
And when you talk about this thing, vectors are nothing but we can consider as an n dimension array.
Mm-hmm.
Matrices are nothing but matrices are also n dimension array. And what it does is the higher. So basically, you can actually convert anything to an higher dimensions. Okay, that will see efficiently support operations on both CPU and GPUs.
Mm-hmm.
Okay, that's why we use tensor. Enable automatic differentiation and ensures about training neural network. So this is very important. We'll check this in a bit. I have the document ready. Differentiation. Okay.
Mm-hmm.
Now essential for training allow seamless conversion to okay, basically the best part is that if you are very comfortable in like NumPy,
Mm-hmm.
so if you are comfortable with creating NumPy arrays and dimension arrays in NumPy, what you can do is you can actually really easily transition. Basically you have a NumPy array and you want to convert it into a tensor, so there are inbuilt functions that you can directly use to convert that into that way. Okay.
Okay. Uh-huh.
Okay, now let's start with importing it. Okay, we'll import torch and we'll import numpy as np. Okay, so we can use any short name as well, torch for like as tp, something like that, but
Yeah.
let's keep torch for now.
Okay.
So let's let it import. Okay, that is imported. Now directly how to create a tensor? Tensor is create. We can create a tensor very easily. So you just have to pass a list or maybe n dimension array. So
Mm-hmm.
what's an n dimension array? And the difference between, do you know the difference between list and ND array? Any idea?
I use list, but ND array, no, I haven't used this. ND array?
Okay, I'll tell you.
Uh-huh.
Yeah. So I'll tell you what this ND array is. ND array is nothing but so basically N stands for N dimension array. Okay. It could be 2D, 3D, or 4D. Like based on number of rows and columns, it you can consider that as 2D or 3D the array. Okay, what array means? Array means the data type is linear throughout, which means if you create an array with number, all the elements should be a number. That's what an array is. The difference between list and array is nothing but in array you can only have a single type of data type, whereas in a list you can have multiple data type. That's what array means.
Okay.
Okay.
Uh-huh.
Okay. So here, if you see, right, we have created two lists and they are of same data type. What we are doing, we just have to using torch.tensor and we are providing our what we say list. It's
List.
working fine. So this is how we define our first tensor. Okay. You can pass any array and you can convert it using the torch.tensor method. Okay. Now,
Mhm.
if you want to convert from an NP array, so how you can do is np.array. Okay. First,
Mhm.
we are creating an NP array. Okay, we
Okay.
are defining a variable, and what we are doing, torch from NP array. We are using this method to convert this NP array into our tensor. Okay,
Mhm.
is it clear? Now,
Yeah.
basically, when you yeah, now basically from another tensor, if you want to like work with another tensor, like if you want to replicate another tensor, you can use one likes operation. Okay, this operation you can perform, and what it will do is it will actually replicate the tensor for you. Okay,
Can you print each of them? Just like to see the difference of what it would be like a X data in this block, right?
from
Can
here,
for X data print X data and
yeah,
print
sure,
X, yeah.
got it.
Yeah, XP, yes. Oh, it printed?
So yeah, so
Hmm.
yeah, printed, yeah.
Okay.
So it's showing tensor in the front,
Mm-hmm.
and let's check the data type as well. I think this won't work. So let's use type function in Python. Type x underscore data. Okay, we'll just have to print it. Print. See,
Partial.
torch or tensor.
Okay.
Yeah. So that's the data type,
Mm-hmm.
and yeah.
So,
So basically, here we can see this how it looks.
okay, and the next line you are again converting into XNP, right? So in the next line from
Hmm?
NP array, then you're printing it, right? What's the difference? Can you
Yeah.
print the data type of XNP?
Okay. You want the data type of this, right?
Yeah, yeah,
I'll just copy this line.
yeah, yeah.
So okay. Yeah. Let's see. Okay. So basically, what we're doing, first we are creating np.array. Np.array is nothing but it would be an array,
Mm-hmm.
right? We'll do this. And in the next line, what we'll do, we'll see the data types of both that we get a clear idea. X underscore np. Let me run it. See, it's a numpy array. So basically, numpy nd.array it is showing,
Mm-hmm.
right?
Okay.
And this is the toss tensor, right?
What's the difference between them? Where we going to use NP array?
Okay.
Because both are.
Basically,
Hmm.
hmm,
Yeah, go on, sir.
tell me.
No, no, go on, Kumar.
Yeah.
Yeah.
So basically, to be honest, like when you're generally working with like GPU like oriented system,
Mm-hmm.
and at that time you can use the tensor part, but the operations are quite similar. So you can choose any of these, like if you're comfortable. Yeah, it's like that.
Okay, okay. I'll
Yeah.
share on a screen,
So
which I'm writing it. But
hmm,
just keep it down. I will discuss in the end. Yeah, yeah. In the
yeah,
WhatsApp.
sure.
Yeah, yeah. Go on, please.
Yeah.
Um,
Now in the last line, what we're doing, we're just using the randit function, rand like function. So what it will do is it actually will create a random tensor for you in which the data type is nothing but float.
mhm.
So here we are getting and x underscore data. Where do we have x underscore data? Yeah, we have it, right. Okay, what exactly it does? So basically, when you do rand underscore like, what it will do is actually it will generate numbers between 0 and 1.
Mhm.
So that's what we are getting. And here we are passing x underscore data so that it will have the same structure like x underscore data.
Okay, okay.
Okay. Now let's move ahead. Create a tensor with constant and random values using shape. Okay. Now basically shape we have defined 2 comma 3, which means 2 rows and 3 columns. Okay. And okay, what we are using rand underscore tensor, torch or rand. So what it will do, it actually generate a random, it will take random values from 0 to 1.
Mm-hmm.
And the dimension is what? 2 cross 3, which means 2 rows and 3 columns.
No.
Okay. Now what is this once? Once is like all the elements it will keep as 1 for you. So it's a shortcut way. What is zeros? It will create a 2 comma 3 like 2 cross 3 matrix in which every element will be 0 for you.
Okay.
And here the by default data type is nothing but float. So here you can see every data type you say is float. Okay. Now basically if you want to change the data, what you can use? You can use this.
Mm-hmm.
Just copy it and print. Okay, I'll just put here. Rather than float, what I want, torch, I'll just wait torch dot. I need to wait. Is it coming up? No. Torch torch dot. Let me do int. Maybe it should work. Let's see. If it fails, let's see. Int 64 I have to put, I guess. Yeah.
Mm-hmm.
Uh, it's not showing that attribute. Dot. Wait. I want to see the all that attributes it can support.
Okay. Uh-huh.
Okay. Okay. Here I got it. If I want to work with data, which is nothing but integer. Test I. Okay, I got it here. So int type. Here it is not. Okay, int 64 is there, right? Yeah, I did it. I'll just run it. But it's not working. I need to use maybe a function.
Mm-hmm.
Okay, not this way. Toilet data is not. Okay, I think it's not working. But how we can do it? Actually, we can put a data type as well. But why it's not working? Give me a second. Torch dot. It should work this way. Okay, now let's do np dot. It should also work. I'm sure. So, even this should work. It's not working. Okay, it's not working. Okay, got it. But what we can do is the main agenda is that we can put data type as well. I'll just rectify it in a bit. But by default, data type is what? By default, data type is nothing but uh, float. But you can put any data type you want using this way. I'm not sure why it's not taking all that parameters. Why it's taking float. Give me a second. I'll just verify it.
Mm-hmm.
Dot. Let me wait for a couple of seconds. So when you put a dot, actually it will show all the method. Okay, I got it. It'll show all that method that it supports input. Okay, all this. Uh, yeah, all the data types are there technically. str is also there. Yeah, np dot array. Okay. Length. Okay, I'll fix it. Okay, let me do this. Maybe it should work. It didn't work. Uniform not implemented for int. Okay, I think there's something mismatch, but I'll get it fixed. No issues. But what's the main agenda? Basically, the data type by default data type is nothing but float, but
Mm-hmm.
you can change data type when you're trying to create the nd array using this d type function. Okay, using
Okay.
the d type function, you can put the data type of that nd array. Okay, now let's move ahead. Now, same way, we're using torch. Okay, torch.rand, and we are giving a dimension of 3 comma 4. Okay, shape of the tensor. So basically, tensor.shape, we can get the shape. D type, we can get the data type, which is nothing but float 32. And the device, here we can see CPU, right? Now, basically, what is this? So basically, you can actually configure the like GPU as well. Basically, there is a command. So using that command, what you can do is you can set everything to use GPU. Basically, here I am using the collab free version, so it doesn't support GPU. So,
Mm-hmm.
but if you want to do that, you can do that as well. And what it will do is actually it will like speeden up the compute for you. It's like that.
Okay. But what you substitute in the
So
place
the
of
command
device, number of CPU? You
here, okay, no. Basically, you want to know that command, how we
no
move
no
to this?
no.
Hmm?
So I mean, what you substitute in the value tensor.device, what would do? What would say? What
Okay,
like?
it is saying that currently it is using GPU, CPU. But if you like switch the machine, then it will say which machine exactly it is using. Is it using CPU or GPU? That's what it will say.
Okay, okay, okay. Got it, got it.
Yeah. Okay, now let's move ahead. So basically, the same way that we do indexing and slicing. Okay, here you can see CUDA, right? CUDA is nothing but like tensor equals to tensor.to CUDA. So what we are checking, move tensor to accelerator if available. But here we can see like what I said right earlier, moving CPU to GPU. CUDA is nothing but CUDA is like a GPU maybe by NVIDIA or something. Let me check. CUDA. Oh yeah. So CUDA is nothing but it's like a GPU offered by what? Your NVIDIA.
Mm-hmm. Okay.
Okay. When you move that, when you use that command, that's the command which actually moves the whole system. So basically, what it is doing, CUDA is available. We are using this, and tensor equals to tensor dot to CUDA. So basically, it's not happening currently. Now, if I run this, maybe okay. I think it won't because actually I'm using this version, the free tier version, so it's not working.
Mm-hmm.
So basically, if it was available, it would move the acceleration or the compute to this CUDA, or it will start using GPU for you.
Okay.
Okay. Not talking about slicing and indexing. Slicing and indexing are typically same as we do in array.
Mm-hmm.
Okay, a normal array. So we just have to put, indexing, right? In slicing.
In list, right? Yeah, yeah.
Yeah.
In
So
indexing,
basically a list or
in a
yeah.
list or in tensor?
No, no. It is similar to that list only.
Okay, then it's fine. Yeah, I have it.
Yeah. So basically what we're doing here, we are just what we did, I'll just tell you. So what we did, we actually created a like tensor, like with a dimension 4 comma 4, 4 rows and 4 columns, and in which I have put every value as zero once. Okay, like we can use the zeros method or ones method. So currently I'm using the ones method, and what it will do is if I want to print the first row, what I can do, I can use 0. So I'll get the
Mm-hmm.
first row. Okay, if I want to get the first column, what I could do? Okay, so basically here there are like two concepts. I'll just quickly give a recap. Uh, so basically, there are two things, right? Rows and columns.
Yeah,
So whatever you want to access in rows, you have to put before the comma. Whatever you want to access in the column range, you can have to put after this comma. Okay.
yeah. Okay.
Before comma, if you put, it will select the rows, and if after that comma you put, it will select the columns. Okay. Now basically, in columns and rows, both you can do indexing and slicing. What is
Can we
indexing?
do
Indexing
ranges
means
in the rows? Can we do the
hmm,
row in ranges in the rows? Say like okay, set up like a
hmm,
6x6 and or 4x4, like limiting the rows. So
hmm.
printing the row from 2 to
Yeah,
3. We can.
definitely. I'll show you. Okay. Yeah. See. So basically, let's do it. See, this is the end result, right? Now, basically, what I want is actually I want one, two, three, four, four rows and maybe like 3 columns.
Mhm.
Do we want to do that?
Yeah, yeah, yeah.
Okay, yeah, definitely we can do it. Basically, if you see, like how many rows we want, like
Four
basically for
rows.
this
Yeah.
operation, 1, 2, 3, and 4. Basically, 4 rows we want, right? I'll just do
Yeah.
it. So I'll just put a comma if I want to select the rows, right? What is the range of rows? The first, it is starting with 0,
0.
index 0, right? Then I'll
Okay.
put a colon, okay? 0, 1, 2, 3, okay? 0, 1, 2, 3. So basically, I have to go through here, right? So what I'll put, I'll just put 1 plus, like it should be 4. 1, 2, 3, 4, 4. Okay. Now, how many this
Uh,
rows are done? Column I want this column. I want
Second column.
from this. What is the index of this? 0, 1.
Yeah.
The starting index is nothing but 1. And I'll give a colon. And I want to go till where? 0, 1, 2, 3, 4. I want to go till 4. So I'll just put 5 here. Just run it. Here you can see. Is it working?
No. Okay.
No, no, no.
Yeah,
It should
just come
include the
back
0
to
as well, right? No, no, no. Sorry, sorry. It's perfect. Yeah, it's working. I need to put something else in the. So how we can do it? Give me a second.
No, this is fine. I think I can call. I mean, Pandas also has the same, right? Data frame, same method. So that's
Yeah.
what.
So basically, mhm.
Yeah, yeah,
So it's done, right?
yeah, yeah. Done, done.
So basically, the reason why we didn't understood because like this is the different operation we are performing here. That's why we got confused. But Yeah, basically if you work with different ND array, we can do it. So this is how we do it.
Okay, so data filtration, what we do in pandas can also be done through tensor? No, right? We don't. No, I'm just curious to understand. We are using pandas, right? In pandas, we are doing data filtration, changing the columns or
Right,
something. But
right. Yeah.
tensor, are we use tensor as a replacement of pandas? No, right?
No, no, not really. No,
No, no. Okay, okay, okay. Yeah, yeah.
no. Okay, let's continue. So this is like slicing. This is the slicing part. So
Mhm.
when basically we are just slicing the 2D array. Basically, if you want to slice 3D array, you actually have to put. Okay, I actually have a notebook ready. Let me show you that.
Temperature upheld at +13 degrees.
Give me a second.
Yeah, yeah.
Your times digits recognition using ANP. Section 14 NumPy advanced. Okay, I think fundamental we can check. Give me a second. See, the difference here, if you see, right? Importing NumPy as NP, tensor is nothing but torch. You just have to put torch. Just like that. See, NP dot ones is there, right? But what you are putting? Torch dot ones. NP dot zero was there, right? What you are putting? Torch dot zeros, right?
Okay. Yeah, yeah, yeah.
Yeah, that's how we do it. Now, linspace
This
we
is
don't
just
want. This way.
as of now, we are just generating the data, right? I mean, generating an array, look like a matrix, right? The
Yeah,
same
yeah.
we
No, it's metrics only.
matrix only. The same thing we can also do it through NumPy. NumPy also we
Yeah,
can
that's
an array,
yeah,
right?
yeah,
But
yeah.
on what case it differ, right? As you mentioned, the
Mhm.
only difference is it can handle this one, GPU engine. That's a difference where
Yeah,
NumPy differ, right?
yeah, yeah. That's what it is. But
Okay.
if we do more quick like comparison, basically in
No, no,
NumPy we
no,
generally do when we don't need. Hmm,
no
hmm.
problem, no problem. I'll read it. No issues, no issues. You go with the flow. I have one thing
Yeah,
to take, but I'll show you in the end of the meeting. While you complete
yeah,
this.
sure. Yeah. Okay, now let's move ahead. I'll just show you some index and slicing. Okay, so basically what we have.
No, these are NumPy here, Kumar.
Yeah.
No,
So
you are.
actually, I'm just showing that. Hmm,
Uh,
I was just showing that indexing and slicing part.
okay, okay, okay. Got it. Got it.
Okay. So this is like how it is. So I'll just quickly print A2. Here
The
A2 is
double
there,
colon.
right?
What is a double colon? I see what double colon, right? It's a mistake.
Yeah. Which one? Which one?
No, no,
That I
it
use?
just yeah, you it here one double colon, double colon. I used to see one
Yeah.
colon. What is a double colon?
Okay, I'll tell you. Double column means jump. It's like a jump factor.
Uh-huh.
It's like a jump factor. Basically, there are two things. Rows and columns, right?
Yeah,
This is for rows and this is for columns.
yeah,
And this is for starting point, end point, and there's
yeah.
another thing called as jump. Start, end, and jump. So basically, when you start at 0 and you end at 10, and
Mm-hmm.
you want jump of 2 each. So you have to put a jump of 2. So what
Oh,
it will do, the first will row will be 0, then second will be 2, then 4, then 6, then 8. So the third value stands for jump. So if you see the outcome here, if we, okay, I'll just explain this outcome maybe. So basically what we're doing, we are starting at index 0, not just row and column. We are just talking about a column, right? How is the column? 0. So these are the columns. It is starting at this, okay? It is starting at 1, 5, and 9. Okay, 1, 5, and 9. And basically it is going till where? It is doing a jump of 2. So it's skipping this 2, 6, 10. Can you see? In this example. Is it okay?
Okay, okay, Kumar, just 1
It's
second.
jumping.
Just
sure.
1 second.
சொல்லுங்க
Yeah.
நாளைக்கு சொன்னா கூட போதும் கன்ஃபார்ம் பண்ண முடியுமா சார் 6:30 to 7:30 இல்ல 5:30 to 6:30 அது அது
சார் 6:30 to 7:30 எனக்கு ஓகே சார். அந்த டைம் கொஞ்சம் பெட்டரா தான் இருக்கும். 6:30 இல்ல. Sorry, Kumar. Yeah, we continue.
Sure. Okay. So this factor I was explaining about jump.
Yeah,
Here
yeah.
you can see, right? I'm just
Yes.
talking about the columns. So it's starting from 1 and it is going till the end. And it's having a jump of 2, which means it is skipping this 2, 6, and 10 wala part.
Okay. It's skipping the first row,
So-
right? In this case, it's skipping the first row in this case.
Yeah, it's just starting with the first
First
row
row.
and is skipping the second one, the index 2 one.
Okay, 5 and 7. Okay. Okay. But
Is
why
it clear?
it is, yeah, why it is okay,
Skipping
0
it?
to, no, got it. Yeah, understood.
You got it right?
Yeah.
Okay, I'll just remove it for now. Let us see. So all the rows will come. But if I put it back, like if I had a jump of 1, nothing will happen. Okay, nothing will happen. If I had a jump of 2, so this is happening. If I had a jump of 3, 1 row will only come. Right? One
Yeah.
column only will come.
Mhm.
It's nothing but starting point, end point, and jump point. That's it.
And
And the first was is for row, second is for column. That's it. The same we were doing here as well. Let me come back. Yeah, that's what we are doing here. Same, whatever we saw in NumPy, we can do it. But the thing is, tensor we have to put. Okay. So
Okay.
first column, if I want to print first column, what you have to do? I have to just put colon. Basically, you have to put colon. What colon will do? It will select the start point and end point. When you don't put anything, it will select the most lowest start point and the highest end point. It will put it on its own.
okay.
So basically, to select the column, we are doing this. Rows, we are selecting all the rows. 0 means the 0th column. Okay. Now,
Okay.
0th index column, right? Now, talking about last column. Last column is what? Dot and -1. So this is why we are putting dot. This is the way we do it. That's like that. Basically, if you want to like reverse a ND array, you just have to put colon -1. So that's like by default. Nothing to like. There's no logic in it. So you just if you want to reverse it, last column you can do this, and this is the end like
Yeah.
negative indexing.
Reverse the last column is last column, the
Yeah.
reverse order.
Okay, I'll tell you. Basically, when you are operating an 1D array, right?
Okay.
Let me show you. In NumPy, if I am operating a 1D array, I'll just open. See, basically, see, this is my 1D array, right?
Yeah.
0, 1, 2, 3, 4, whatever it is.
Okay.
If I want to reverse it, what I'll do is I'll put A1 square bracket colon -1. Here, if you see 9876, it reversed, right?
Okay. Can we do it for even for the 2D arrays? This type of thing? Just curious. No, how to do it? Just
2D array, no, I'll tell you. In 2D array, do we want to reverse it? No. So for 2D array, how we do it? We use transform function. .t. Transpose, it's transpose. It's not working. Should work.
Here we will use this type of
It
thing,
work.
Kumar. So basically,
So,
uh-huh.
So what is that? That is known as transpose function. It is related to
Matrix.
what we say set matrix. Matrix related. It's a matrix function.
In application way, they will using it. Why we are transposing the matrices and all?
Okay. Basically, I'll tell you. When we want to match the dimension generally, like basically, if you have like 2 rows and 5 columns, when there is a mismatch of number of rows and columns, but the input you want is you want it to be flattened. Like
Okay.
it should like you don't want that box. You want like you want the column focused one, something like that. For that need, we transform it. Are you
Okay.
able to get it?
Yeah.
Yeah, basically we want just to change the dimension. Like rather than 2:5, we want it 4:2. Oh, no, sorry. 2:5, we want it 5:2. We just want to change the rows to column and columns to rows. That's it. And why we need it? Because we want to match a transformation, or we want to do a matrix multiplication or some case like that.
Okay.
Yeah.
Kumar.
So for that purpose, now let's move ahead. So this is clear, right? Move tensor to
Yeah.
accelerator if available, that we done. Indexing and slicing, the similar one.
Mhm.
Okay, joining tensors. How we can join tensors? So we can use the cat function. Cat is nothing but concatenate function. We can
Mhm.
concatenate more than one tensors. So basically, the similar tensors that we created above this value, we're just concatenating multiple times. That's it. And dimension we are passing dimension 1. So basically, there is 0 and 1. I'll just do 0. See, 0 means row and 1 means column. That's like that. Make sense?
It is look like a transpose, right? It is just
Yeah.
transposing it.
Yeah. 2 will won't come because there's nothing to do with 2.
Mhm.
So basically, what 0 will do, 0 will do it row basis. Like what it is doing, adding rows, like all the rows. Are you able
Mhm.
to get it?
Yeah,
So
yeah.
basically, number of rows will increase. So here you can see all the rows it added. Now you do one. One means like it is adding side by side, which means number of column will increase eventually. So that's what it is, dimension. So in dimension, you can select in which direction you want to concatenate, whether you want to do it row wise or the column wise. That's what dimension is highlighting. And cat means concatenating the tensors. Tensor 1, tensor 2, and tensor 3. Basically, they are three same tensors. That's why here the result is.
Mhm.
Now let's move ahead. Now this is arithmetic operation. Okay, this is the transpose. T. T for transpose.
Okay.
And okay, tensor into tensor, we're just multiplying tensor into tensor. MUL means multiplication. Rand like means you just generating random values. And multiplication means MUL, you're just multiplying two tensors. And T means transpose. Yeah, that's what it is.
Okay.
Yeah. So basically, these operations, you might be feeling a bit like you won't be able to get it. But once you do NumPy, right, all this will make sense because NumPy and set all the operations are same only here.
Do you use in the data engineering this thing?
NumPy?
Tensor or NumPy? No,
No,
right?
not really. We generally use pandas. The reason
Yeah.
we use pandas is that generally the data type, the data we get is generally JSON or it's like CSV. That's what we deal with.
Okay.
JSON, CSV, or yeah. So NumPy, I haven't used that much to be honest.
Ah,
Basically, the data scientist guy generally use it. The data scientist person,
okay.
like do some numerical calculation, finding the loss function or some like doing some mathematical function on top of your values. So
Okay.
they generally use it.
Okay. Kumar, the time
Okay.
is going to end. Can I give a new one
Then-
or you want
yeah,
to
sure.
tomorrow? Okay.
Hmm.
Um,
I think today we got enough about tensor. Maybe we can continue tomorrow as well. Tomorrow,
sure.
what we'll do is from now onwards, we'll speed up everything.
Uh-huh.
Like so, basically, tomorrow onwards, we'll like do really in depth. We'll create a model, and there are like pre-built data sets as well that is available. We'll be using that, and from now onwards, we can connect every day like 6 a.m. every day. I have like
Okay.
rescheduled my timings. Is it
Okay.
fine, right?
I
Yeah,
hope
today
so.
I was a bit late.
No problem, Kumar. Actually, what happens, sometime I have to go, I'll come late from office. Only those days will be
Hmm.
little hard. But anyway, that time I'll let you know earlier. I'll
Yeah,
the day before.
hmm,
I just need
sure.
work. Can you, if you share the
Hmm,
screen, just want to show you
hmm,
something.
okay.
We'll continue tomorrow, but just to show some code and in the WhatsApp I just pinged you.
Okay, I'll just check now. Okay,
There
I'll
are
just
two
copy it
codes.
and put it in.
Yeah. First
Hmm,
code, which is like, the images, I'm taking an image and extracting the array out
hmm,
using OpenCSV, I guess.
okay.
Okay. And then I'm storing it is
Hmm,
I'm using TensorFlow on this one. And I'm just creating a pickle out of all these changes. We are doing
perfect. Hmm,
TensorFlow and Keras model. I'm not the one who written it. It is written by some ML engineer in the team. I'm just managing it.
hmm,
Uh,
hmm.
if you come, the other script
Got
which
it.
you just
I'll
pasted,
share mine.
Yeah.
Hmm.
Which is like what you're teaching in the torch. So there is something called distributed data parallel in as DDB. I think model distribution and data distribution, right? So
Right.
as you know, like I'm appending all the images and I storing it all the vector out of each image and storing it somewhere, and I'll do the prediction. So this I'm going to do almost like a 4,000, 5,000 images. So each one would have
Got
different.
it.
So training would takes around 2 hours. Okay, for 5,000 images and
Got
all.
it.
Okay, so
Right. Yeah.
I instead of this, can we use the distributed data parallel method in DDP just for the purpose of training?
Yeah, definitely we can do that. Yeah.
Yeah, I don't want you to work on it. Just just a high level. If you can explain tomorrow, right? It will be also helpful. You go with the just one or maybe 5 minutes max related to it. The rest you
Yeah.
continue topic.
Like, can you like, just like, can you ping it in WhatsApp once?
I
Like
pinged in the WhatsApp only.
the agenda?
Okay.
No, the
Sure,
agenda.
Agenda.
So
Sure,
what we'll
sure.
do is, yeah.
Sure. I'll ping you that
Yeah.
one. Yes.
So, yeah. So I might forget, like, yeah, what
Yeah,
exactly we're
I
talking
understood.
about.
Sure. Sure.
Mm. Okay, you want me to review this code, or like, should I explain you?
No. I will. I'll go through it and I'll ask questions tomorrow. You don't even need to.
Yeah, definitely.
Okay.
Yeah.
Okay.
So we are connecting tomorrow, right?
Yeah. Yes.
Okay.
Okay.
Okay. Thank you, Brian. Let's connect tomorrow, no?
Yeah. Thank you, Kumar.
Yeah. Okay.